A Lynis hardening index can rise while the machine still has serious gaps. So this is not a score-chasing exercise. Audit and modify only a Linux machine you own or have explicit written authorization to administer. Define its role in maintenance window, use a disposable VM or container snapshot, back up every file you touch, and write down the rollback before changing anything. My controlled lab is a local Kali 2026.3 container, pinned to one image digest, with networking disabled, every Linux capability dropped, and no new privileges. A full disposable VM is better for boot, firewall, storage, and service checks. The container is here to teach the audit loop. On an owned Kali host, run sudo apt update, sudo apt install Lynis, then Lynis show version. This tested image reports Lynis 3.1.6. Upstream 3.1.7 exists, so record the version you actually run. Run the baseline with sudo Lynis Audit System Quick No Colors Auditor owned disposable lab. Quick mode removes the pauses, no colors makes the evidence easier to preserve. Root is not mandatory, but it reveals more detail. Lynis writes technical detail to /var/log/lynis.log and report data to /var/log/lynis-report.dat. Copy both before the next scan because Lynis purges the log on every run. Also sanitize host names, users, package inventories, network details, and host identifiers before sharing anything. Our baseline produced one warning, 38 suggestions, and index 57. Filter the report with sudo grep warning //suggestion hardening _index equals /var/log/lynis-report.dat, then search the log for the test IDs you plan to review. A warning is not automatically a vulnerability, a suggestion is not automatically safe to apply, and an OK is not proof of security. For each row, record the finding, local evidence, exposure, likely impact, operational cost, owner, decision, and rollback. Package currency and exposed services may outrank the tidy configuration changes shown here. The lab selected 3 findings that all trace to /etc/login.defs. AUTH-9230 found no configured SHA crypt rounds. AUTH-9286 flagged the default minimum and maximum password ages. AUTH-9328 found no OMask there. The reversible script preserves the original file, removes active duplicate keys, and adds SHA crypt rounds of 5,000 to 10,000, password age defaults of 1 in 365 days, and OMask 027. Those values satisfy the tested Lynis 3.1.6 checks, they are not universal policy. SHA crypt settings may be irrelevant when another hash method is active. Password age defaults may not alter existing accounts. OMask 027 affects defaults for newly created files and may break shared workflows. Review PAM, account state, service accounts, and your approved policy first. Now run the identical audit again. AUTH-9230, both AUTH-9286 suggestions, and AUTH-9328 disappear. The index moves from 57 to 60, while LOGG-2138 and many unrelated findings remain. That is the useful evidence, the same test IDs changed after one recorded edit. It does not mean the machine became 3% more secure. The rollback restored the original file byte for byte, its SHA-256 matched the baseline, and a third audit brought all 3 IDs in index 57 back. There is one more trap. LOGG-2138 says clogged is not running, but systemd is not PID1 here and the kernel belongs to Docker desktop. That warning needs validation on a full booted host, not a blind container fix. Lynis scans opportunistically, so different machines receive different tests. The index summarizes applicable test points, it is not a vulnerability inventory or a security guarantee. Keep the habit instead, preserve the baseline, trace IDs into local evidence, rank by exposure and impact, make the smallest approved reversible change, test real user and service behavior, re-audit, and document accepted or deferred risk. Authorize, snapshot, audit, inspect, decide, change, verify, and keep the rollback. Copy the Lynis checklist from the description, subscribe for more defensive Kali labs, and explore the WSQ cybersecurity courses below.